Hi guys, this video is going to be talking about volume in terms of modeling. When we say modeling, we're talking about real world modeling situations, so we're talking about real world shapes, but taking them to the classroom by transforming them into 3D shapes that we know of, where we can still calculate volume, surface area, circumference, etc. using formulas from our reference sheet. So I put some real world pictures here. We're just going to identify what they are as far as our 3D shapes go. So you can see in this first picture on the left, on the top left, we've got some pyramids. Those are from Egypt, but we know that we can find the volume of a pyramid using our reference sheet. Right below that we have a basketball. That basketball represents our sphere. Next to that we have this Voss water bottle. This water bottle is in the shape of a cylinder. Going up to the Superman lunchbox, we have a rectangular prism. And next to that we have this water tower, which is actually made of 3 different shapes. The first one on the very top is a cone. The second one in the middle is a cylinder. And the third one on the bottom is actually called a hemisphere, because it's half of a sphere. And then this traffic cone is also made of 2 different shapes. The top part is the cone, and the bottom part is a rectangular prism. When we do modeling, sometimes we have to convert units. So we've got 2 examples here. The steps are listed out. The important thing to understand with the steps is that I like to use a proportion. You can do this in different ways, but my method is a proportion, where we keep the numerators the same and keep the denominators the same. So you match top with top, bottom with bottom. And then you just cross multiply to solve because it is a proportion. So in this first example, it says the volume of a sphere is 5,780 cubic centimeters. Determine the volume in liters to the nearest tenth of a liter. If you look at your reference sheet, you'll find a formula that tells you how to convert between cubic centimeters and liters. I believe it says 1,000 centimeters cubed equals 1 liter. So we transfer that equation into a fraction, where we put 1,000 centimeters cubed over 1 liter. And then we say equals, centimeters cubed are on top, so we need our volume in centimeters cubed, 5780 centimeters cubed. And we're looking for the volume in liters, so we say x liters. From here, we cross multiply. So we have 1,000x equals 5780. We divide by 1,000, and we have x equals 5.780, except we need to round to the nearest tenth. Remember, that's the first decimal place. Looking to the right tells us we have x equals 5.8. So the volume in liters is 5.8 liters. If we look at the next example, we have a hemispherical bowl where the volume is given as 486.56 feet cubed. The material that the bowl is made out of weighs about 0.43 pounds per cubic foot. That's the conversion we're going to use. We're not going to look at the reference sheet. It's already given in the problem. And our goal is to find the weight to the nearest pound. So our first step here is to take this thing in the red box, 0.43 pounds per cubic foot, and change it to a fraction. 0.43 pounds lb. Per means division. 1 foot cubed. We say equals, we don't know the number of pounds that we're going to have, so x pounds over 486.56 feet cubed. From here we cross multiply. X equals 209.221, and rounding to the nearest pound means a whole number, so 209 pounds. Again, you'll get more practice with conversions in just a few minutes on the Common Core questions, but there is one last little thing that I want to talk to you about, and it's percents. Remember that percents are always out of 100, so we can use this proportion to help us find the percent of a container that's either full or empty, which we'll see from a Common Core test if we flip our paper over. The first question we have here says a shipping container is in the shape of a right rectangular prism with a length of 12, a width of 8.5, and a height of 4. If you want, you can sketch this. Start with a rectangle, draw another rectangle diagonal and to the right of it, then connect your vertices, top with top, bottom with bottom. It has a length of 12, a width of 8.5, and a height of 4. Our goal is to find the weight in pounds. Notice though that they gave all of these units in feet. And there is a conversion right here. It's kind of tough to see, but it does say 0.25 pounds per cubic foot. So our first step is to find the volume, and then our second step is to convert from feet cubed to pounds. So finding the volume of a rectangular prism is not on the reference sheet, but we have 3 dimensions, a length, a width, and a height, and we multiply all of them. This is a formula that you have to memorize for your exam, so please get that stuck in your head. We have 12 times 8.5 times 4. If you want to practice typing this stuff in on your own calculator, then I suggest you pause the video while you type it in, because I've already done these calculations, and just to keep the video from being like 6 hours long, I'm going to give you the answer right away. However, I strongly suggest that you do practice typing them in, especially when we get to stuff with like the pi symbol, because you need to practice typing it in before you take your test in June. So when we type in 12 times 8.5 times 4, we end up with the volume is 408. But remember that this is in feet cubed. All of those dimensions they gave us were feet, so feet times feet times feet gives us feet cubed. But now we have to convert. So remember this purple box that I have in my sentence up here, my problem. It says 0.25 pounds per cubic foot. Change that to a fraction. 0.25 pounds per, meaning division, 1 foot cubed, equals, we don't know the number of pounds, so x pounds over 408 feet cubed. From here we can cross multiply. We have x equals 0.25 times 408 gives us 102. Choice 3. In question 2, again, all of these are coming from Common Core exams, so please understand that if you're not understanding this, you need to pause it, rewind it, go back, ask your teacher for help, do something, because these questions come up often on the Common Core tests. We have a hemispherical tank that's filled with water, and it has a diameter of 10 feet. Water weighs 62.4 pounds per cubic foot. What is the total weight of the water to the nearest pound? So again, we're going to have to calculate the volume, and then we're going to have to convert. This time, we have feet cubed going to pounds again. So volume of a hemisphere is going to take the sphere formula, 4/3 pi r cubed, and divide it by 2, because it's a hemisphere. I'm just going to carry my work over here to the left so that I have space. We have v equals 4/3 pi. We need the radius cubed. They give us the diameter, so that means that the radius is equal to half of that, being 5. And then don't forget, divide by 2. If you're practicing typing in this calculator, again, I strongly suggest it. Type the top part in first, then type divided by 2. Once you do that, you get 261.799. From here, I'm going to convert this to pounds. So we take this statement, 62.4 pounds per cubic foot, and change it to a fraction. 62.4 pounds per, meaning division, 1 foot cubed. And it's equal to, we're trying to find out the nearest pound, so x pounds, we don't know what it is, over 261.799 feet cubed. Cross multiply, and we end up with x equals 16 16,336.3, 16,336.3, which is closest to choice 1. The next question is going to take us away from volume for a second, and it says that we have to create perfectly circular necklaces. So if you just kind of sketch a necklace, maybe it's got some beads going around it, who knows. They tell us that this necklace, as beautiful as it is, has a radius of 10 centimeters. And we're asked what is the largest number of necklaces that can be made from 1,000 centimeters of wire. If you think about the wire on a necklace, the wire goes around the outside edge of the necklace. That's related to the circumference of the circle. And you do have a formula on your reference sheet for circumference. It's C equals, well, if you look at your reference sheet, there's two different ones. There's C equals pi d or C equals 2 pi r. Since they gave us the radius, we might as well use 2 pi r. So 2 pi times 10. When you type in 2 times pi times 10 in your calculator, you get 62.8319. Now, normally we don't write units, but I just want to talk about it here. This is saying that we have each single necklace needs 62.8319 centimeters of wire. Centimeters for one necklace. So now your goal is to figure out how many necklaces can we make if we have 1,000 centimeters of wire. You could take 62 and add it to itself continuously until you get to 1,000. See how many times you added it. You could also multiply it by different numbers to see what gets you to 1,000. But the easiest option here would be to take the 1,000 centimeters that we have and divide it by the 62.8319 centimeters that we need and get a value of 15.9155. Now, we can immediately cross off choice 3 and 4 because those are not even close to 15 or 16, but we really have to decide here, do we have enough wire for 15 or 16 necklaces? If I were to cut it off at 15, that means I have a little bit extra of wire or of necklace that I need to make. 16 is too high. I don't have enough wire for it, which means we have to stick with 15. Number 4 says that Molly wishes to make a lawn ornament in the form of a solid sphere. The clay being used weighs 0.075 pounds per cubic inch. The sphere's radius is 4 inches, and your goal is to figure out the weight to the nearest pound. This is like questions 1 and 2. So first step, volume. Second step, convert. I'm going to ask that you do this independently. You're going to need your reference sheet for this so that you can find your formula for a sphere. And you're going to be able to check in with me because I'll do it on this video silently without talking so that you guys have a chance to practice independently. Pause the video at any point in time if you feel as though you need to. If you need more time, just pause the video. My final answer was choice 2. If you're ready to move on, move forward with me. If not, just pause the video, rewind it if you need to, so you can see me walking through the work. Alright, so moving on to number 5, it says the diameter of a basketball is approximately 9.5 inches. and the diameter of a tennis ball is approximately 2.5 inches. Notice that in both of these they give you diameter. However, in all the questions that we've done so far with volume, we need the radius. So remember that D is twice R, meaning diameter is twice the radius. So if they give you diameter, we need to take that diameter and divide it by 2. So 9.5 divided by 2 gives us 4.75 as the radius for the basketball. For the radius of the tennis ball, we take 2.5 and divide it by 2, and we get 1.25. Our goal here is to figure out how many times greater the volume of the basketball is than the volume of the tennis ball. Since they're talking about volume, we should probably calculate volume. So you're going to do this in two separate steps at first, and then our third step will be to figure out how many times larger the one volume is than the other. So first let's do volume of the basketball, then we'll do volume of the tennis ball, and then we'll figure out the number of times greater. These balls, basketball, tennis ball, soccer ball, any type of ball except a football, is in the shape of a sphere. If you look at your reference sheet, volume of a sphere is listed as 4/3 pi r cubed. So this will be the formula that we use for both of them. So we have 4/3 pi. The radius of the basketball is 4.75, and we're raising it to the third. Practice typing this in. If you do that, pause the video because I'm about to give you the answer in 30 seconds. But you should practice on your own. Volume of the basketball comes out to be 448.921. For the tennis ball, we have 4/3 pi. The radius was 1.25, and we're raising it to the third power. Again, practice typing it in. Pause the video yourself if you need to. Volume of the tennis ball comes out to be 8.18123. So to figure out how many times greater the volume of the basketball is than the tennis ball, we could take 8.18 and add it and add it and add it and add it continuously until we get to 448. And then count how many times we added it, but that's obnoxious and ridiculous and too time consuming. We could also think about multiplying 8 times 1, 8 times 2, 8 times 3, kind of like a guess and check to figure out how many times it can go into 448, or we can do the reverse. Take the volume of the basketball and divide by the volume of the tennis ball. This will tell us our answer immediately, instead of taking all that extra time. So 448 divided by 8.18, of course those decimals are still there. We're going to type all the decimals in the calculator, and we get 54.8721. This rounds to 55, choice 3. Just a reminder that all of these are Common Core questions, so if you're struggling, make sure that you stop, you pause, you rewind, you refocus, and ask your teacher for help because you have to be able to do questions at this level of rigor. Number 6 says a fish tank is in the shape of a rectangular prism and has the following dimensions: 14 by 16 by 10 inches. The tank currently contains 1,680 cubic inches of water. What percent of the fish tank is empty? So all of these numbers in our choices are actually percents. 10%, 25%, 50%, and 75%. Our first step is to figure out the volume. Second step will be to figure out the percent that's full. And then third step will be to figure out the percent that's empty. Remember, this is a rectangular prism. Volume of a rectangular prism is a formula you must memorize. It's a nice easy one: length times width times height. So we have 14 times 16 times 10. When you type that in the calculator, we get 2,240. So this is the entire volume, meaning the whole. The part that it's filled up with is the part. Remember, we talked about a formula on the front of our reference sheet that said percent out of 100 equals part. over whole. We're going to find the part that's full by using part and whole, or the percent that's full rather, and then subtract from 100 in the end to find out the percent that's empty. So we have x over 100, because we don't know the percent, equals the part 1680 over the whole 2240. Go ahead and solve for x by cross multiplying. When you cross multiply and then divide, you end up with 75%. Remember that this is the part that's full. So to find the percent that's empty, we take 100, we subtract the part that's full, 75, and we get 25% empty. Meaning, choice 2. Number 7 says a gallon of paint will cover approximately 450 square feet. An artist wants to paint the outside surfaces of a cube measuring 12 feet on each edge. What is the least number of gallons of paint he must buy to paint the cube? Take a second with me and sketch a cube. Start with a square, draw another square diagonal and behind it, and then connect top with top, bottom with bottom. And one edge is 12. But this is a cube, and remember that cubes have all sides equal. Every single side on this cube is 12. So if we think about covering the outside of this cube, that means that, say I want to cover this surface with paint. I also want to cover the top surface with paint, and the bottom and the sides and everything else. So that means that we're talking about something called surface area. This is far less common than volume in terms of the Common Core exam. This is the one and only question they have asked about surface area, but it's still something that you should know going into the exam. So surface area is calculated by finding the area of each of the sides and then adding it all up. But with a cube, all of those sides are going to have the same exact area, especially since they're all 12 by 12. So if you think about finding the area of a 12 by 12 surface, we take length and multiply it by the width. Don't attempt to multiply it by the height, that would give you the volume. So we have 12 times 12. But there are 1, 2, 3, 4, 5, 6 of the same exact surfaces. So we have 6 times 12 being typed into our calculator. And that gives us 864. That's for surface area. But we're trying to figure out how many gallons of paint we need. This is feet squared because we had 12 times 12 feet. Feet times feet gives you feet squared. So our second step is to figure out the number of gallons. Each gallon covers 450 square feet, and we need to cover 864 square feet. So we're going to take 864 and divide it by 450. This gives us 1.92. So we've seen a question like this before where we have to decide on how to round. Remember that we're trying to cover this entire surface, so if I purchase 1 gallon of paint, would that be enough to cover all of the surfaces of the cube? Hopefully you're saying no, which means that this time we have to round up, unlike the necklace problem where we had to round down. Number 8 was actually not a Common Core question, but it's something that I can imagine them asking on the Common Core question based on the level of rigor here. We have a rectangular container with dimensions of 21 by 38 by 12 inches, and it's to be filled with water using a cylindrical cup with a radius of 5 inches and whose height is 8 inches. What is the maximum number of full cups that can be placed into the container without the water overflowing? So if I'm filling up the container with cups of water, that's talking about volume. So first we're going to find the volume of the rectangular prism. Then we're going to find the volume of the cylinder, and then we're going to figure out the number of cups. So I want you to take a look at your reference sheet. I'm going to do this silently up here on the video. If you need to pause it at any point in time, that's fine. Otherwise, let it run while you work, and then we'll talk about how to find the number of cups. You probably need more time to find the volume, so if you do, just hit pause. Otherwise, follow along with me so we can find out the number of cups. To figure out the number of cups that we need to fit inside of this container without overflowing it, we're going to kind of do it like we found out how many times greater the volume of the basketball was than the tennis ball, where we take the volume of the rectangular prism and divide it by the volume of the cylinder, or the cup. So we have 9576 divided by 628.319. When we divide, we get 15.2407. So remember that we are not allowed to overflow the container. So you're asking yourself, is 15 enough or is 16 enough? If I try to fit 16 cups into the rectangular prism, we are going to be overflowing the container, which means that we round to 15 cups. Flip it over, we have one more type of Common Core question for you before you get on to your practice. So question number 9 is actually a 3-part question, meaning it was probably worth 6 points. I can't exactly remember, but with it being 3 different questions in total, I would assume 2 points apiece. Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8 inches and a diameter, all the way across, of 3 inches. To the nearest cubic inch, what will be the total volume of 100 candles? So first, let's find the volume of one candle. Then, after that, we'll find the volume of 100 candles, meaning the volume of the total. So because the radius is half of the diameter, where the diameter is 3, the radius halfway across is 1.5. You might be asking how I got 1.5. I just simply took 3 and divided by 2. Volume of a cone is given to you on your reference sheet. 1/3 pi r squared h. So we have 1/3 pi. R will be replaced by 1.5. Square it, and then multiply it by the height, 8. When we type this in the calculator, we get 18.8496. Again, this is the volume of one candle. 1C, one candle. So we have to take this and find the volume of the total. So this means that we have 100 candles times my volume of one candle. And this gives us 1,884.96. But we're talking about nearest cubic inch, so we have to round. The 4 looks to the 9, which tells us that we have 1,885 cubic inches. Walter goes to a hobby store, something like Michael's or Joann Fabrics, to buy the wax for his candles. The wax costs 10 cents per ounce. And if the wax weighs 0.52 ounces per cubic inch, how much will it cost him to buy the wax for 100 candles? So we're going to kind of ignore the first volume that we calculated and focus on the second volume. The first step is to convert to ounces. Convert inches cubed to ounces. Because the cost is per ounce. So we need to know the volume in ounces so that we can find the cost. So the conversion for ounces was given in the second statement. 0.52 ounces per cubic inch. 0.52 ounces per 1 cubic inch is equal to, we don't know the number of ounces, so X ounces over the number of cubic inches we had, 1,885. When you cross multiply, we get 980.2 ounces. From here, we have to find the cost. You can do this in 2 different ways. The first way is just simply multiplying. So 10 cents, 0.10 for every ounce, and we have 980 of them, 0.2. This gives us $98.02. Or you could do your cost with a conversion. You'll get the same answer either way, so it doesn't matter. It says 0.10 cents, or 10 cents per division 1 ounce equals X dollars over 980.2 ounces. You can see that when we cross multiply, we have X equals these two values being multiplied, which is what we just did back up top to get the 98.02. Last part to this question says that Walter spent a total of $37.83 for the molds, and he charges $1.95 for each candle. What is Walter's profit after selling 100 candles? Now, if you think about profit, that's a relationship between the amount that you've made and the amount that you have spent. Typically, you make more than you've spent, otherwise you wouldn't be doing it. So amount made minus amount spent will give you your profit. He's making $1.95 for every candle, and he's selling 100 candles. So we start by taking 100 and multiplying by $1.95. But we still need to subtract off what he's spending. And he's spending two different amounts here. Remember, he's spending $37.83 for the mold. But he's also spending 10 cents per ounce of wax, which we calculated to be a total of $98.02. So we're going to keep this 100 times 1.95. You can multiply those immediately, and it's giving you 195. But we have minus, combine these terms inside the parentheses, and you get 135.85. So his profit, when we subtract them, ends up being $59.15. So he makes about $60 after selling 100 candles. I don't know, you tell me if it pays off, I'm not sure. Before you move forward, make sure that you're comfortable with this content before trying the practice and your assessment. If you have any questions, remember, ask the teacher around you or go back and revisit a particular part of the video. Thanks for sticking through it. I know it was a long one. Good luck and have a good night.